Welcome to TDS Online Math. Now in today's tutorials, we are going to look at one of the important topics in mathematics, that is circle theorems. Okay, so this topic, so far as core mathematics is concerned, is very important. Okay, now let's consider this circle. Okay, now we have the important part, that is the center here. Now the center is very important for a circle. Once we know the center, we can locate our radius. Now from the circumference here to the center, so we have radius. Okay, so we can have another radius here, we can have one here, can have one there also. So that's the radius. Okay, now knowing the radius, can also talk about the diameter. So diameter, so that is the sum of the two radii. Now let's call the side x, o, y. So we know line xo is radius and line yo or oy is also radius. So radius, that is the diameter. So diameter is the sum of the two radii. So d is the same as twice of r. So it means to find radius, you can divide diameter by 2. And to find diameter and you're given radius, you can multiply it by 2. Alright, that's that. Now let's talk about a chord. Okay, so x, y. Okay, now a chord is a straight line joining any 2 points on the circumference, but does not pass through the center of the circle. Okay, so we can have a chord here. So let's call this side mn. Can have a chord here. Okay, and what have you? That's a chord. Now that we know what is meant by a chord, let's talk about segment. Okay, so we have segment. Once we know a chord, we can find a segment. So if this side is a chord, so that would be the segment. Okay, as simple as that. All right. Okay, now let's talk about a tangent. If a line touches a circle at only one point like this, it's called a tangent. So we have a tangent line. We can have a tangent here. So if a line touches a circle at only one point, it's called a tangent. Sorry, that's that. Now let's talk about a secant. Now with a secant, it touches a circle more than one point. So we have this. Okay, so we can have a secant here. Now let's notice this, a secant and a chord, the difference. Okay, so this one is a chord and this one is a secant. So this one crosses the circle, this one it doesn't. So it doesn't cross the circle. So this one is a chord and this one is a secant. Very important. All right, so that's that. Now knowing the parts of circle will help us understand the theorems very well. Okay, so let's look at the first property here. So the first property talks about the angle at the center. Okay, the angle which an arc or a chord subtends at the center is twice the angle the same chord or arc subtends at any point on the remaining part of the circumference. So angle which an arc, so have an arc here. Okay, there's an arc this way. Okay, so the angle that this arc subtend, okay, at the center here, the angle here, okay, so it's twice the angle the same chord, okay, subtend at any point on the remaining part of the circumference. So it means that when this side is x, this side is 2x. That's the first property. Okay, so let's call this side M N O P. Okay, so it means angle M, okay, angle MON is twice of angle MPN. Okay, that's the idea. It means that when I divide both sides by 2, it will be half of angle MON will be the same as angle MPN. So when you divide this side by 2, to give you this side. Okay, all right, so that is the first property I will talk about. Now I use arc here. Now tomorrow can be a chord like this. Okay, chord, so we know what is meant by chord. So the angle which an arc or a chord subtend at the center is twice that of circumference. Okay, so that's that. Now we can have so many scenarios here. Okay, you can have so many examples. Okay, so if this side is 30, this side will be 2 times 30, that will be 60. That's the idea. Okay, all right. Now they can also form the same angle like this, so something like this. Okay, so you can form it like this. So this one, same thing. So if this side is X O N P, okay, angle, okay, angle X O N is 2 times angle XPN. So same thing. So I haven't changed anything. I just push it from here, and don't forget that it can happen at any part of the circumference, so note that. All right, so we can also form one here. Okay, so let's call this side K. So same thing, angle XON, that is this side. Okay, so it is same as twice of angle XKN. So that's that. So if this side is, now let's talk about the second property. So the second property talks about angle in opposite segment. Okay, angles in opposite segment, they add up to 180 degrees. So now that is how it behaves. So opposite segment, that's the first one. Another segment, so MNTP. Okay, so let's call this side X, and let's call this side Y. So per this property, So we have the first segment A, and then we have another one AB. So we have opposite segments. So the sum of the angles here will be 180. X plus Y equals 180. All right, that's that. So you can have so many examples. All right. Now let's go ahead with the next property. All right, the next property has to do with angle subtended by the same arc or chord, okay, anywhere in the same segment are equal. So if there is a chord, okay, so we have an angle forming here, okay, we have another one here, the same chord, and we have another one here, okay. Same chord. Okay, so let's call this one chord XY. All right, so once it happens this way, the angle here, this side is X and this side is Y, this side is Z. Okay, let's call this side X, M, and P. So we have angle XMY, that is X. Okay, so X is the same as Y. Okay, X is the same as Y, the same as Z. So angle XMY, this one, the same as this and the same as that. Okay, because of this, let me call this one TK. Okay, TKM. So angle X is the same as angle, so the middle one TMK. TMK. And the same as Y. Y is TNK. TNK. And the same as P. TPK. Angle TPK. Okay, which is the same as X, Y, and then Z. Alright, so if this side is 30, this side will be 30, and this side will also be 30. Alright. Okay. Now, we also have equal cos, okay? Equal cos or arc, subtended equal angles at the center and the circumference of a circle. So we can have equal cos at the center here. So let me get a chord here. Let me do it well. So okay, and we have another one here. So we have a chord, we have a chord. It means the angle here is the same as the angle here. Okay, so if this side is 40, this side is also 40. All right, so we have a chord here. So, and we have the one here. So another chord. Okay, so the angle here, this side is X, this side is equal to Y. So angle X is the same as Y. Okay, that's that. Okay, so if this side is 40, this side is 40. Okay, all right. Now we want to talk about a diameter. Okay, we know what is meant by diameter. So any angle subtended at the circumference of a circle by its diameter, okay, is a right angle or it's 90 degrees here. So in case in the question it says if XY is a diameter, it means the angle that subtends here is 90 degrees. Okay, it's 90. So let's look at another scenario here. So in case you have, let's say, a diameter, okay, say AB. AB is a diameter. Okay, it means the angle that subtends the circumference here is 90. But if this side is, let's say, 20, and you are asked to find angle ABC. If AB is a diameter, okay. Now, once AB is a diameter, the angle that forms the circumference here is 90. So this one will be angle BAC plus angle ACB plus angle ABC equals to 180 degrees. So the sum of angles in a triangle add up to 180. So we have BAC as 20 plus ACB as 90 plus ABC. So let's call the side X. ABC X equals to 180. So we have 110 plus X equals 180. So X is 180 minus 110. So X is straight away 70. So this side is 70. Okay. That's the diameter of a circle. Okay. How powerful it is. All right. Okay. Now the next property has to do with angle between the chord and tangent. All right. Now the angle between the chord and tangent is equal to the angle in the alternate segment. So if this side is theta 1, so in alternate segment this side will be theta 1. Okay. If this side is theta 2, let me use different color. So if this side is theta 2, this side is the opposite or alternate. This side is the alternate segment, that will be theta 2. Okay, so that's that. So if this side is 30, this side will be 30. And if this side is 20, this side will be 20. So that is the angle between the chord and the tangent. Okay. All right. Now let's talk about this. Okay. So we have 50 here. We have X here. We have 25 here. We have Y here. Then we have M here. Okay. So if you have to solve for M, X, Y. Okay. So from here, Y is 50. Then X is 25. And this one is angle in a straight line, which add up to 180. That will make this side go to 180. All right. So after this, we are going to solve so many examples. So don't worry about the examples. Okay. All right. Now let's talk about the cyclic quadrilateral. If this one, okay, we have 4 points quad touching the circumference. Okay. We call it a cyclic quadrilateral. So once it happens, the sum of the opposite angles add up to 180 degrees. So A plus D is straight away 180 degrees. Then B plus C is also 180 degrees. All right, so this one is called a cyclic quadrilateral. All right. Okay, so if this side is 70 and this side is Y, so what is X? So it's straight away adding the two and equating them to 180. So 70 plus X is 180. Therefore, x is the same as 180 minus 70. So x is straight away 110. Remember, when we sum the two, you get 180. And if this side is 60, you should know this side as 120. All right, so that's that. Okay, so I will talk about the tangent to a circle. Okay, remember, if a line touches a circle at only one point, it's called a tangent. Now, we have a tangent here. So once this side is a tangent, this side is 90 degrees. Okay, and we have another one here, 90. Okay, now if this side is m, this side is m. Remember, we have radius from here to here is radius, so they are equal, and therefore this side is equal to that. Okay, and once this side is equal to that, it implies that this side is also equal to this side. So if this side is 20, this side will be 20, and this side is 40, this side will be 40. And don't forget that this side plus this side plus this side will give us 180 degrees. Likewise here, plus there, plus over there also give us 180 degrees. As simple as that. Now, let's talk about the first example. Now, before we talk about the first example, the sum of angles in a triangle, okay? If this side is alpha, theta, and this side is beta, alpha plus theta plus beta will give us 180 degrees, okay? Now, when we have two parallel lines like this, okay, and this one is a transversal, we have so many properties. So if this side is x, okay, so this one corresponds to that, so this side too is x, and this, if this side is t, we have vertical opposite angles, x equals to t, and remember, x alternate to t, so we have an alternating angle here, tx. If this side is m, this side is opposite. If this side is u, okay, once we sum this one, we get 180. So the angle here is the same as the angle here. All right, so that's that. Now, knowing these things will help us, solve a lot of examples, okay? All right, so let's start with our first example here. So now that we know the properties, we can solve this example. So let's call this side A, B, C, okay? And we have O. All right, now we had solved for x. So our x will be angle AOB. Now remember the first property, okay? The angle at the center is twice that of circumference. So when we have this, not drawn to scale, now if you have something like this, okay, an angle at the center and that of circumference. So if this side is k, this side is 2k. Now we have 70 here, so this side will be double, okay? All right, so that's the first property. So angle AOB, okay, the same as twice of ACB. Now the middle one is our target, so ACB means that this side 70. So 2 times angle ACB. So angle AOB is twice of that. So this side will make it 2 times 70, which is 140 degrees. So this side is 140. Okay, so that's our first example. All right. Now let's talk about our second example. Remember, the angle at the center, okay, that is twice that of circumference. Now, the angle forming at the circumference can be formed at any point on the remaining part of the circumference. So, remember the first one we solved, we found our angle here, but this time it has been pushed down here. Okay, so the value is the same, the theorem still remains the same. So what we have here, okay, is twice of that. So same thing, angle B is 2 times angle ACB. So this is ACB. And what is ACB? ACB is 120. So 2 times 120, that will be 240 degrees. So AOB is now 240. Remember, when this side is given, we should be able to solve this by dividing this side by 2. Okay. Now let's talk about the next example. Yes. So this time we have the angle at the center. So let's see how the angle at the circumference will be. Alright, so remember the theorem which says the angle at the center is twice that of circumference. So angle AOB is 2 times angle ACB. That is what we know, but we know AOB as 100. So I'll put 100 here. 100 is the same as we after this side. So AC is what we are after. Okay, so ACB, this side be 2 times angle ACB. Now many students find it difficult to write this thing, so they normally represent this side by variables unknown, like saying ACB is P, then they put P here. Okay, so we can go ahead with that. So let's divide this side by 2. So this side will cancel. So we have 50 equals angle ACB. So once we double this, you get this. All right. Okay, now we have to solve for angle AOC and X. Now remember that we have 2 segments here. Now let's put A. Okay, this is the first segment. Okay, now a segment. Now look, angle in opposite segment. So this is the first segment, and we have another one here. Okay, now forget about the angle at the center here. Okay, now the first segment and the second segment, once you put them together, you get 180. So if this side is X and this side is Y, the sum of angle in opposite segment give 180 degrees. So that will help us solve for X. After that, we come back to O. Now don't forget that we just saw an example of this nature. So the angle at the center, this is a chord, AC is a chord. The angle at the center here is twice that of circumference. So AOC is simply twice of 80. Okay, that will be 160. So this side is 160. We just solved 2 examples here. Now to find X is simply angle ABC, that is X, plus angle ADC, that is 80, equals 180. So angle ABC plus 80, ADC, this is ADC equals 180. So angle ABC equals 180 minus 80. So angle ABC is straight away 100 degrees. So this side is 100. So the sum of these angles gives us 180 degrees. Okay, that's that. All right, now let's solve this question with ease. So this one is not all that difficult. Okay, so let's understand this one again. So there's angle at the center. Okay, then angle at the circumference. So I can choose, let me call this x, and I can choose to push x to this place, okay, that is here, and I can also push this one to this side, so that is r. Good. But remember, we were not given this side, we were given this side, and remember this angle at a point, so we have it here, angle at a point, so it add up to 360 degrees. Okay, so we are going to find POR reflex. Now let me explain this one here. Now we have POR, so we have at the back here and we have in front here. So one is reflex and one is obtuse. Okay, now obtuse is less than 180, okay, but more than 90. Reflex is also less than 360 but more than 180. So guess which side will be the reflex and which side will be the obtuse. So the 100 will be the obtuse part. So angle POR obtuse plus angle POR reflex will give me 360 degrees because there's angle at a point. So everything here will be 360. So with this 100, okay, 100 plus angle POR reflex will give me 360. So angle POR, that's the reflex, okay, will be 360 minus 100. $260. So this side is 260. And if this side is 260 and this side is unknown, so PQR will be half of 260. That will be 130, 130. All right, so that's that. Right, let's look at the next example here. Now, the line DC, okay, the line DC is a tangent to a circle. So we have DC here, it's a tangent. Now remember the alternate segment, okay, you said this side, if this side is theta 1, this side too is theta 1, okay, and if this side is alpha, this side is alpha, okay, that is what we said. All right, now let's go ahead with the question. Now angle BC is 61, angle BC, so this side is 61, okay, so BC is 61, and angle DCA is 68, so this side too is 68. Okay, now the question says find the side of the angle CAB. So the question says find angle CAB, this side, okay, so angle CAB, okay, is simply now 61 degrees, okay, so it's simply 61 because this side is a property, is a theorem here, okay, so this side and this side are equal 61. Okay, now find the size of angle ABC. So this side too is 68, so ABC is 68 degrees, okay. All right, now let's find the size of angle ACB. Remember that to find angle ACB, that is this side, okay, you mean this side. Remember this is a straight line, so angle on a straight line, so it will be like this, okay. So we have 68. This side is unknown, and we have 61. So angle on a straight line add up to 180. So angle DCA, that is 68. Angle DCA plus angle, so ACB plus angle, okay, BCE will give us 180 degrees. 180. So DCA is 68 plus angle ACB plus 61 equals 180. So we have 129. So we have angle ACB plus, so we have 129 equals 180. So angle ACB, 180 minus 129, okay, 129, 15. So we have angle ACB as 51 degrees. Okay, so 51. All right, so this side is 51. Okay. O is the center of the circle. So O is the center, okay. Now we have to find the side of the angle FGH. Now, if this one is a straight line, okay, so this side is 180, okay, and this side is also 180. That will make it 360, okay. So half of this side, okay, half of angle FOH, okay, is angle FGH. So this side is 90 degrees. And it's the same as if FH is a diameter, the angle that's subtended the circumference is 90. So this side is 90. Now, if FG is the same as GH, FG is the same as GH. So if this side is R, this side too is R. So the question says find angle GFH. GFH. It means this side. Okay. So from there, we can say that angle GF, okay, H plus angle FHG plus angle FGH equals 180. Now we are saying FG is the same as G, so the lengths are equal. So it means if this side is R, this side is what R. So F is R, H is R, plus 90 equals 180. So we have 2R plus 90 equals 180. So 180 minus 90. So 2R 90. So R is 90 on 2, which is 45. So this side is 45 degrees. Therefore, have 45 degrees here. All right. O is the center of a circle. Now, two tangents to the circle touch the circumference at the point A and C. B is the point where the two tangents meet. Angle OBC is 44. OBC. Now before that, if this side is a tangent, so this, sorry, so it's a tangent, so this side is 90, and you have the same thing here. This side is 90. Oh, sorry, this side is 90, and this angle is the same as this angle, and this side is also equal to this side. Okay, so once we know these rules, it will be easier and faster. Okay, now let's go to the question. Okay, so angle OBC is 44. This side is 44. So this side too 44. Okay, this side too 44, and this side will be 90. And if you have to find this side, it will be easier and faster. Okay, so find the size of angle ABO. ABO is 44. Don't waste time. Find the size of angle OCB. OCB is 90 degrees. OCB is 90. COB. COB. This side. So we have angle COB plus angle OCB plus angle OBC equals 180. Okay, so COB is unknown, OCB is 90, OBC is 44, equal to 180. So 90 plus 44, 4, 10, 31, 34. Angle COB 134 is equal to 180. So COB is 180 minus 134. 10, 6. So we have 46. So this side is 46. Okay, we have 46 here. Okay, and this side to be 46. All right, so that's that. Now the next example here, you can pause the video and give it a try. So this one is very simple. Okay, so either this one is an arc or a chord, the idea is the same. Okay, now O is the center of the circle, so angle FOE is 118. So we have 118 here. Find the size of FD. So FD is angle FD is half of angle FOE. FOE. That is half of 118. Okay, 118. So we have 2, 5, 10, 2, 9, 18. So we have 59. Okay, so I find the size of the angle OEF. OEF. So OEF. Okay. OEF. We want this side. So let me OEF. Let me draw this line well. So OEF. So this side is equal to this side because they are all radius. So this side is the same as this side. So angle OEF plus angle OFE plus angle FOE equals to 180. So remember, OE and OF are the same, so let's label it as X. So this side is X. Okay, so X OEF plus OFE, X plus X plus 118 equals to 180. So we have 2x plus 118 equals to 180. So let's solve x here. So my 2x is the same as 180 minus 118. So 180 minus 118. So 62. So we have 2x equals to 62. Therefore, dividing both sides by 2 will make this side 31. So OEF is 31 degrees. All right. Okay, so GHO and JIO are triangles. Okay. All right. So remember, if JH is a chord, okay, and O is the center here, the angle that's subtended at the center, okay, is twice the circumference here. So we have this one. Okay. So if this side is x, this side will be 2x here. Okay. All right. Then we have the same thing here as well. So if this side is also x, this side will be 2x. Okay. Now angle OGH is 21. OG, so this side is 21. And OIJ is 42. JGO, so JGO is also 33. JGO is 33. OIJ is 42. And OGH. Okay. The question says find J. We want this side. So once we know this side, we can find this side. So 33. So let's call this side Y and this side M. So O is the center. So twice of this will give us that. Okay. All right. So angle to find O, okay, that is M. So angle GOJ, that is M, okay, is 2 times angle GIJ, okay, or OIJ, okay. So angle GOJ is 2 times 42. That will be 84. So this side M is 84. You have this side as 84. It means Y plus 84 plus 33 equals 180. Remember, Y is angle GJO. So Y is the same as angle GJO. So GJO equals Y. So whatever answer that we get to be Y. So we have Y plus, so 117 equals 180. So Y equals 180 minus 117. Okay, that will be 53. 117 3, sorry, 63. So we have 63 as, okay, simple as that. The line PQ is a tangent to the circle. So if this side is a tangent, PQ, okay, it means this side is empty and this side is empty. Okay, let's understand that. O is the center of the circle. O is the center. So this side is the same as this side. Okay, all right. Now angle NPQ, NPQ, NPQ is 1 to 1. So NPQ, I think this side, okay, is 1 to 1. So everything here is 1 to 1. But this side alone is 90, so we can find this side. So 1 to 1 minus 90. So we have 1, 12, that is 3, 31. So this side is 31. Because this side is 90, so plus 31 will make 1 to 1. Okay. And the question says find the size of angle NOP. NOP, so this side. And don't forget, if this side is 31, this side will be 31. So angle NOP plus angle OPN plus angle ONP give us 180. Angle NOP is unknown. OPN is 31, then ONP is 31 equals to 180. So angle NOP plus 62 equals 180. Okay, so angle NOP 180 minus 62. Okay, so 180, that would be 118. So 10, 8, 7, 1. So we have 118. So this side is 118 degrees. Okay. Now you can pause the video and give this one a try. Okay, so WVX is a tangent to a circle, to the circle. Okay, WVX is a tangent to a circle. O is the center of the circle. Angle TVW is 48. So TVW. So this side is 48. And if this side is 48, this side to be 48 because of alternate segment theorem. Okay, and this side is equal to this side. Okay, so the question says UTO is the same as OV, so it means this side is the same as this side. Okay, all right, so find UVX. UVX, so we want this side. Okay, UVX. All right, now this side is 48, and if this side is 48, we know TVO is angle at the center, so this side will be double. So 2 times 48 will be this side. Okay, we have 61, so we have 96 here. And if this side is 96, so the flex part will be 360 minus 96. 360, 96, 10, 4, so 15, 6. So we have 264. So this side is 264. So 264 plus this side plus this side plus this side will be 360 degrees. Okay, all right. Now remember we have the UVX, and to find UVX is the same as T. It's same as UT. So once we know this side, we can also know this side because this side and this side are equal. Okay, and once we find this side, okay, so let's name this side X. And name this side X. So X plus X plus 264 plus 48 give us 360. 360. Okay, so 2x plus 264 plus 48. So 2, 1, 10, 11, 1, 3, 1, 2, 360, 2x, 360 minus 3, 1, 2. So 360, 360, 312, 10, 8, and this side will be 4, 48. 48. So over 2 over 2. So that will be x equals to 24. Okay, so this side, let me name this side. This side is 24. So we have 24 here. And we have this side as 24. Remember, this side is the same as this side. So once we know this side is the same as that, so UTV is the same as UVX. Okay, so if this side is 24, let's find this angle here. But remember, this line is the same as this line because they are radius. So 96, let's call this side P. Let's call this side P. So P plus 96 will give us 180. Okay. So once we get P, we'll add to 24 to get the answer for UVX. So P plus 96 equals 180. 2P 180 minus 96. So 180 minus 96, 10, 4, 17, 8. So 84. So P is 84 on 2. That will be 42. Okay, so if P is 42, it means angle UTV is 24 plus 42. That will be 66. And angle UTV is the same as angle UVX. That is 66. So we have 66 degrees. Okay. All right. So that's that. Now let's look at the next example. Now TB is a tangent. So TB touches the circle at B. So if it happens this way, what is here is the same as what is here. Okay. And we have the same chord here. This side is the same as this side. Okay. Now the question says find angle ABC. ABC. So ABC is the side. Okay. How do we find this side? Remember, we have a cyclic quadrilateral. So this side plus this side will be 180. This side plus this side will give us 180. Okay. Now, this side will alternate to this side, so 31 here. And this side is the same as this side, 69. So angle ADC is 31 plus 69. That is angle ADB plus angle CDB. So angle ADC 31 plus 69. That will be 100. So this side is 100. Now, how do we find ABC? Angle ABC plus angle ADC equals 180. So angle ABC plus ADC has been found as 100 equals 180. Therefore, angle ABC 180 minus 100, which is 80. So this side is 80 and this side is 100. Okay. Now let's talk about CAD. CAD is this side. Okay, but we know this side, so let's find this side. Now don't forget that BD is a diameter. If BD is a diameter, it means the angle that subtends the circumference here is 90 degrees. Okay, so everything is 90 and this side is 69. What will be this side? So that I think it will be 21. Okay, so this side will be 21. All right, so that's that. So we have this side as 21 degrees. All right. Now ABCD is a cyclic quadrilateral. So same thing. So if this one is a cyclic quadrilateral, the sum of the opposite angles add up to 180 degrees. So we have this one here. So 3x plus 2x will be 180 degrees. Okay, so 5x got 180. X the same as 180 on 5. So 5 here, 5 3 15. So 36. So x is 36. But the question says we should find ABC. So ABC is the side. But 4x minus 45 plus angle ABC equals 180. But x is what? 36. 4 times 36 minus 45 plus angle ABC equals 180. So 36 times 4, 2, 12, 14. So we have 144 minus 45. So 144 minus 144 minus 45. So 14, 5, 9. 9 here, and this side is 3, 13, 9. So 99. So we have 99 here. Okay. All right. So let me change the color. So we have 99 plus angle ABC equals to 180. So angle ABC 180 minus 99. Okay. So 180, 99, 10, 1, 17, 17 minus 9 is 8. So angle ABC is 81. So we have 81 here. Okay, so 81. All right. Now let's find the angles in the quadrilaterals here. So we have B, we have A, we have D, we have C. Okay. All right. So this one is not 100% accurate. So now let's see how we can find ABC. ABC. So ABC. Look. ABC. Okay. It's this side. But we can extend this line. So this side is behaving at angle of straight line. So 75 plus ABC will give us 180. So I angle ABC plus 75 give us 180. Therefore, angle ABC 180 minus 75. Okay, so 10, 5, 0. So we have 105. So angle ABC is 105 degrees. Now let's go to BAD. BA, so this side. So same format, same formula. So II angle BAD plus 84 give us 180. This side. So angle BAD 180 minus 84. So 180, 84, 10, 6 here. So angle BAD is 96 degrees. Okay. So we have this side A as 105, and we have this side as 96, 105. So this side plus this side will give us 180. This side plus this side give us 180. So this side is 105. This side will be 75. And this side is 96. This side will be 84. As simple as that. So ADC is 75. BCD is 84. Okay. Now the picture below are two circles, circle 1 and 2. O is the center of circle 1. All right. Now, if this one, okay, is a tangent, so we have this side as 90, this side as 90. So this plus this plus this plus this will give us 360. And this side is alternate segment, so this side equals that. So the question is demanding for x plus y. Okay, so from here we can say 2y is the same as 5x minus 40. Therefore, 2y minus 5x is the same as minus 40. So let's call this one equation 1. Now let's sum the angles here, okay? So 5x plus y plus 90 plus 90 plus x plus y equals to 360. So let's group like terms here. We have 6x plus 2y, 9 plus 9, 18. So we have 360 minus 180. So that will be 6x plus 2y equals to 360. So we can, sorry, this side is 180. Be the same as, so let's divide through by 2. 3x plus y equals 90. So we have this as equation 2. Now from equation 2, y is the same as 90 minus 3x. So let's call it the third equation. So 3 in 1. So 2 times y, but y is 90 minus 3x minus 5x equals minus 40. We have 180 minus 6x minus 5x equals minus 40. Okay, so 180 plus 40 is the same as, so we have 11x. So this side will be 180 plus 40, that's 220. 220 equals 11x. Okay, so let's divide this side by 11. So 11 here, 2, so x is 20. All right, so x is 20. So if x is 20, we can go ahead and find y. So y is 90 minus 3x, but x is 20, that will be 60. So y will be 30. So the question is demanding for x and y. So x is 60, 20, y is 30. Okay, so that's that. TSU is a tangent to the circle, and we have PQRX as a cyclic quadrilateral. All right, so remember the rule that if it is a cyclic quadrilateral, this side plus this side is 180. This side plus this side is 180. Okay, so we have that QPX, Q, so we have that this side, but this side is a tangent. Okay, we have a tangent line here. All right, so angle RSU, this side. Okay, this side is 46. This side is 46. Okay, and if this side is 46, the question says QR is equals to RX. Okay, so it means this angle is the same as this angle. Let's call it R. Call the side R. But because this one is a tangent, everything here will be 90. So R plus 46 will give me 90 degrees. Therefore, R 90 minus 46. So that will be, so 90 minus 46. So we have 44. So this side is 44. And this side too is 44. So we can find this angle. And once we know this side, we can find this side. Okay. So when we add this one and subtract from 180, we get this side. So 180 minus 88. So this side will be 92. So 92 plus this side to give us 180. Okay, so let's solve for QPX. Angle QPX plus angle QRX is equal to 180 degrees. So angle QPX plus angle QRL is 92, 180. Okay, so 180 minus 92, so angle QPX 180 minus 92, that will be 88 degrees. So this side is 88. Okay, so 88, as simple as that. All right, let's consider this example. Now we have ILM and JKM as triangles, okay, and we are given angle MJK. So MJ, this side, MJK, so this side is 33. Okay, now let's not forget this property. So okay, remember this side is an arc, so this side is the same as this side, and therefore this side is 33. Okay, now this one is behaving like a butterfly shape, so this side 33, 33. Now MLI is 47. MLI, so this side is 47. And once this side is 47, this side is 33, we can find this side, okay? So angle MLI plus angle MIL. Okay, let's call this side X. That's the same as angle LMI, that is X. So LMI equals 180. So from there we have 47 plus 33 plus X angle LMI, that is X equal to 180. So 47 plus 33, this side of 80 plus angle LMI equals 180. So angle LMI equals to 180 minus 80, that is 100. It means this side is 100. Okay, now remember this side is opposite, vertically opposite angle, so this side is also be 100. And once this side is 100 and side 33, this side will be 47. So we now have all the size of the triangle. Now let's go to the question. Find the size of the angle LIM. LIM is simply 33 degrees. Now angle MKG. So MKG, that is 47. And angle IML is 100 degrees. That is this side. As simple as that. All right. The line AC is a diameter. Find the size of angle ABC. Now, if AC is a diameter, it means the angle that subtends the circumference here is 90 degrees. So angle ABC is 90. Okay. Now the proof is very simple. Now this side is 180, and if I close it to be 360, and half of So let me call this side O. Half of angle AOC will be angle ABC. So half of 180, half of 180 is 90. So this side is 90. Simple as that. All right. O is the center of the circle. The line XYZ is a tangent to a circle. Find the side of the angle OYZ. OYZ. So if this side is a tangent, this side is 90 degrees. So OYZ is 90 and OYX is also 90. So this side is 90 degrees. As simple as that. Now we have a cyclic quadrilateral. Alright, so IJKL is a cyclic quadrilateral. Remember, if this is a cyclic quadrilateral, okay, so this side touches the circumference. Now the angle here plus the angle here be 180. The angle here plus the angle here, when you sum them, it will be 180. So x plus y equals 180. M plus n equals 180. Now with the question, we have 91 and this side. So 124 and this side. Now the question is demanding for IJK. So angle IJK, that is this side, plus angle ILK, that is 124, equals 180. So angle IJK is same as, sorry, we have plus 124 equals 180. So angle IJK is 180 minus 124. Okay, so 180 minus 124 will be 56. So IJK 56. Okay, all right. Now let's look at JKL. JKL. So angle JKL plus angle LIJ give us 180. Okay, so angle JKL plus, so LI is 91. So we have 91. 91 equals 180. Therefore, JKL got 180 minus 91. So that would be 89. So we have 89 here. We have 56 here. Simple as that. Now the line XWV. So XWV is a tangent to the circle. All right, so this one is the alternate segment theorem. So this side theta 1 is the same as this side theta 1. This side is the same as this side, 58. Okay, all right. Now let's look at the question. Find the side of the angle XWT. So this side. So angle XWT is the same as angle WUT. So that is 58. So remember that here, this side is 58. Okay. Angle UWV. UWV. So this side. Okay. How do we get this side? Once we know this side, we can find that. So angle UWV is the same as angle WTU. So let's find angle WTU from here. Now, angle WTU plus angle TWU, that is 41, plus angle WUT, that is 58, is equal to 180. So angle WTU plus TW, that is 41, plus 58 equals to 180. So angle WTU plus, so we have 99, okay, 41 plus 58, 99 equals to 180. Angle WTU, 180 minus 99. So 180 minus 99 will be 81 degrees. So remember, WTU the same as WV. So we have 81. Now just pause the video and try this, because we just solved similar one. PQRX is a cyclic quadrilateral. So this side plus this side equals to 180. And this side plus this side equals to 180. PQR is 78. Then SRQ is 93. So this plus this side 180. So 180 minus 78 would be 102. Okay, 93 minus 180 will be, so this side will be 87. So SPQ is 87. RSP RXP is 102. So that is that. Okay, in the diagram, O is the center of the circle. OQR is 32. Okay, and MPQ is 15. Calculate QPR. QPR is the side. Okay, so remember, the angle at the center is twice that of circumference. Okay, so angle QPR. Alright, so how do you find angle QPR? Remember, this is a radius, this side is a radius, so this side is 32. So once we know this side, we can find this side. So 32 plus 32 will be 64. So 180 minus 64 will be 116. Okay. 180 minus 64. So half of this side will be this side. So this side will be 58. Okay, this side will be 58. So to find angle QPR here, angle QPR, okay, QPR is half of angle QOR. Now angle QOR is 116, so which is 58. Okay, now the next thing is to find MQO. MQO. Okay, now MQO, so you can pause the video and give it a try. Okay, so this MQO is comprised of this one minus 32, so this side. Okay, so how do you find MQ? Remember, this one is a cyclic quadrilateral, so angle MQR plus angle MPR equals to 180. So angle MQR plus, so 15 plus 58. 15 will be 73 equals 180. Okay, so angle MQR 180 minus 73. Okay, so angle MQR is 107. Okay, so remember everything here. Okay, everything here is 107, but we are after only MQO, so we have to remove the 32 from it. So angle MQO, okay, plus angle O or RQO, so this side and this side, okay, gives us MQR. Okay, so to find MQO, we have to, so this side is 32 and this side is 107, so let's call this side X. So once we remove this one from that will be the result. So 75, so X is 107 minus 32, that would be 75. So this side is 75. Okay, so we have similar one here. So the diagram, O is the center of the circle, PQO is 15 and QSR is 42. Calculate QSP. Okay, so let me show here QSP. QSP, so this side. So remember this side, okay, So once we know this side, we can get this side. But this side is 15. So we have radius here, another one. So this side will be 15 as well. So 15 plus 15 is 30. Minus 180 give us this side. So look at the behavior. Okay. Once we know this side, y plus m plus x will give us 180. So 15, 15, 30. Okay. So 180 minus, that will be 150. So this side is 150. Therefore, angle QSP, angle QSP is half of angle POQ, half of 150. Okay, so that would be 75. So this side is 75. 75. So let's look for RQO. RQO. So this side. Okay. RQ. So let's observe something here. RQO. Okay, so don't forget that this one, okay, is a cyclic quadrilateral. So this side plus this side give us 180. Okay, so angle, so angle PSR plus angle PQR is equals to 180. Okay, but angle PXR is 75 plus angle PSR is 75 plus 42. Okay, so that would be 117. So 117 plus angle PQR equals to 180. Therefore, PQR equals to 180 minus 117. Okay, that will be 63. So PQR, everything here is 63. But we after RQO. Okay, RQO. So excluding the 15, so we have to take 15 from it, because everything we know PQR, but we after RQO. So let's subtract 15 from the 63. Okay, so 63 minus 15 be 48. So we have 48 there, over there. All right. Okay. Now in the diagram, PQRS is the cyclic quadrilateral. PS and QR are produced to meet at T. If PQR is 80 and QRX is 120, find RTS. So RT, this side X. Okay, so this side is a straight line. So 120, this side will be 60. Okay, so cyclic quadrilateral, this side will be 100, because when you put them together, it will be 180. And this side will be 80. It's a straight line. So 80 plus 60 will be 140. Okay. So 80 plus 40. Sorry. 80 plus 60 will be 140. Okay. Now 140 minus 180 will be 40. So the answer is B. Simple as that. Okay. Now you can give it a try. Okay. You can pause the video and give this one a try. So remember PORQ. Okay. It's a quadrilateral. So this side plus this side plus this side plus this side is 360. But we have opposite segment here which add up to 180. So this side is 80. Okay, and twice of this side is this side. So this side is 160. So to find y, so y plus 40 plus 100 plus 160 will be 360. So we have 140. That will be 300. Okay, so 140 plus 160. That will be 300. So 300 y plus 300 equals to 360. Therefore, y is 360 minus 300. That will be 60. So the answer is B. Simple as that. In the diagram above, AB is the diameter of circle ABCD. Now DC is parallel to AB. So DC. So we have two parallel lines here. DC and AB. So let's close this side, okay? And also close this side. Okay, now AB is a diameter. If AB is a diameter, this side is 90. And we can see there is an alternate angle here, Z shape. So this side is 25. Okay. Now we have a cyclic quadrilateral here. This side plus this side will be 180. Now let's find this side. Now the question says find angle ADC. ADC, so this side. But once we know this side, we can find this side. Okay. So let's find angle AB. So angle ABC plus angle ACB plus angle BAC equals 180. So angle ABC is unknown. AC is 90 plus BAC 25 equals 180. Angle ABC plus, so we have 115, okay? So 90 plus 25, 115 equals 180. So angle ABC, 180 minus 115. So minus calculator, 180 minus 115. So it will be 65 degrees. So this side is 65 and this side is 90. But remember, this side plus this side will give us 180. So angle ADC plus angle ABC equals to 180. It's a cyclic quadrilateral. So angle ADC equals to, but let's put this one first. 65 equals to 180. Angle ADC equals 180 minus 65. ADC 180 minus 65. So 180 minus 65 will be 115. Okay. 180 minus 65. 115. So this side is 115. And we have to find CAD this side. So 115 plus 25. Let's put y here. Y plus 115 plus 25 give us 180. Okay. So y plus 140 equals to 180. Okay. So y is straight away 40. So angle CAD is also 40. All right, so that's that. And let's look at the last example here. Now this one is very simple. The diagram WXYZ is a circle with center O. X, Z, and WY intersect at V. Remember, this side will be vertically opposite, so this side is 100. Then half of this side will be this side. So half of angle XOY is angle XZY. Half of 110 will be 55. So angle X, this side is 55. And this side is also 55 because they're equal. And once we know this side has 100, we can find this side. So the question says XZY. XZY. That is 55. Very straight. WXZ. WXZ is this side. So 100 plus 55 minus 180. Okay. Minus 180. So this side will be 25. Okay. Now thanks for watching. Now we can even extend this one. So this one becomes chord. Okay. Alright, so that's that. Thanks for watching. Welcome to another video. Alright. Now let's find angle XYZ. Okay. So angle XYZ. So we want this side. Okay. So this is one of the properties of circuit theorems. Now let's get started. All right, now line XY is a diameter. Okay. Once line XY is a diameter, now let's not drawn to scale. So if I do this and I say AB is a diameter, it means the angle that subtends the circumference here, okay, forms 90 degrees. So angle ACB is equals 90 degrees. All right. Now knowing this condition will help us solve this question. Okay. All right. So remember that angle X, okay, angle XZY, because XY is a diameter, So this side is 90. So to solve for angle XYZ will be very simple. Remember, XYZ is a triangle, okay? XYZ, okay, is a triangle. So angles in the triangles add up to, okay, 180 degrees. Now when you're in this, so if this side is alpha and this side is beta, this side is gamma, alpha plus beta plus gamma will give you 180 degrees. All right. Now from here, angle YXZ plus, so let's solve them proper. So angle YXZ plus angle, so we mean this side, that is a 35, plus angle XZY plus angle XYZ equals to 180. Okay, so angle YX is 35 degrees plus Z, that is 90. So this side is 90 plus angle XYZ equals to 180. So 90 plus 35, 5, 10, 12. So we have 125 plus angle XYZ equals to 180. Therefore, angle XYZ, so that would be 180 minus 125. Okay, so angle XYZ, so 180, 125, 10, 5, 7, 5. So we have 55 degrees, okay, as the answer. So it means angle XYZ here, so this side is simply 55, and since this side is the diameter, so the angle here is 90. So XY is a diameter. Okay, so that's that. All right, so thanks for watching, and don't forget to subscribe. All right, so remember the rule that if it is a cyclic quadrilateral, this side plus this side is 180, this side plus this side is 180. Okay, so we have that QPX Q, so we have that this side, but this side is a tangent. Okay, we have a tangent line here. All right, so angle RSU, this side, okay, this side is 46, this side is 46, okay, and if this side is 46, the question says QR is equals to RX. Okay, so it means this angle is the same as this angle. Let's call it R, call the side R, but because this one is a tangent, everything here will be 90. So R plus 46 will give me 90 degrees. Therefore, R 90 minus 46. So that will be 90 minus 46. So we have 44. So this side is 44. And this side too is 44. So we can find this angle. And once we know this side, we can find this side. Okay. So when we add this one and subtract from 180, we get this side. So 180 minus 88. So this side will be 92. So 92 plus this side will give us 180. Okay, so let's solve for QPX. Angle QPX plus angle QRX is equal to 180 degrees. So angle QPX plus angle QRX 92 180. Okay, so 180 minus 92, so angle QPX 180 minus 92, that will be 88 degrees. So this side is 88. Okay, so 88, as simple as that.